Hey everybody, my name is Jason, also known as Pirate JC, and welcome to another Babylon video. Today I am super excited because we're going to be diving into something that is just plain mind-bending. But don't worry, I don't want to scare you off. We're going to go through everything that we need to do to understand the complexity of what we're looking at today. And what we're looking at is how you can create procedurally generated node materials. How crazy of a concept is that? If you're not already familiar with the node material editor, please check out this YouTube channel. There are a ton of other videos on the node material and how to use the node material editor to create node materials. Essentially what it is it's a node-based system where you can have a tree of nodes that connect to one another to create shaders or programs that run on the GPU to create operations in your scene, okay? It's an incredibly powerful tool. And most people use it doing exactly that, manually dragging in nodes and connecting them to create some amazing, amazing things. But there's another part of the node material that people aren't often familiar with, and that's the fact that you can actually create a node material through code itself. And when you think about creating a node material through code itself, suddenly it opens up some interesting doors, like introducing randomization into the equation. If I can randomly generate node material, then suddenly the possibilities appear completely endless. And that is what I'm so excited to show you today. Now, I do have a small example. Let's check that out here. Essentially what you're seeing is, let me show you the scene a bit. Essentially what you're seeing is just a simple plane that I then have a node material assigned to, and then I am displacing the vertices of that plane by a mathematical operation. Okay, that's essentially what it is. But to get even crazier, notice down here where the GUI says that this signal contains 35 frequencies. This is where some amazing things happen. This particular node material has 35 randomly generated branches, okay? I have a pattern, a branch, a template that I create, and I'm going to repeat and loop over that 35 times to make this particular node material. That is such a crazy concept, but we're just scratching the surface. Let's go ahead and take a look at that. I'm going to open up this node material so we can have a little look. Now, by the way, a link to this particular playground you can find in the description down below so you can follow along. This is the node material. Are you ready? We're going to zoom out. Look at that, 35 different replicating branches that go into making this. Now, essentially, all this is, we've done this many times on this channel, it's a series of sine and cosine waves that are basically added together. That's essentially all that's happening here. And then we pass that into the vertex shader, okay? But what's interesting is the number of different trigonometry operations, sine and cosine waves, the number of those can be randomly generated. And that's what we're seeing here. In this case, 35 of them. Let's go back to the scene real quick, and we're actually going to hit rebuild frequency. Now we have 49, 25. So we're just randomly picking a number of different branches, and that's how many are going into making this particular frequency, okay? Like this one has 8. So when we go back in and open it, again, we have a random number of branches, in this case 8, but like I said, we're only scratching the surface here. It gets even crazier. Let's go in deeper and take a look at each branch. Now, essentially each branch in this case is only 3 nodes, okay? It's a float node, it is a multiply node, and it's a trigonometry operation node, okay? Essentially what happens is I take the X value of my mesh, I have my mesh position, and then I split that off and take the X value, and then I'm gonna multiply that against a random number. Every branch gets a random number. So every frequency is completely different. That in and of itself is another layer deeper and crazy. You want to go a step deeper? Well, the specific trigonometry operation that I'm using is going to randomly select a sine or a cosine operation. What? That is crazy. So I have a randomly chosen number of branches with a randomly chosen multiplier that then goes into a randomly chosen sine or cosine wave, and then we add all those together through a series of add nodes to then move the vertices. That's nuts. It's so cool. And this is just sort of scratching the surface of what's possible. I hope you're as excited about this as I am. You want to take a look through the code with me? Let's do that real quick, okay? Now, on this journey, we're going to look at 3 specific tips and tricks that if you're going to build your own node materials from code, that you're going to want to remember, okay? In this scene, though, it's very, very simple. Like I said, all we have is a camera, a light, and a ground plane. That's essentially it, okay? I also have a variable here called frequency multiplier. You can think of this as the ceiling or the highest possible number of branches that I could have in my node material, okay? Now, this number could be much bigger. I just arbitrarily chose 50. And then the next thing that we're going to do is we're going to select a random number between 1 and that ceiling that we've set, okay? So that is going to be the number of branches that we're going to have. That one line will give us the number of branches, which is awesome. Now, here is where the magic happens, and we'll get into a lot of this in a minute. This is a function that I have down below that actually goes through and creates the node material, okay? I pass in the number of branches, the signal size that I want. That's the number of branches and scene, okay? Now, moving on, we'll get to that in a second. I will return the node material. So after I build it, I will return it with that function. And then I'm going to set the grounds material to be that node material. That's what's happening right here. And then finally, I'm just going to say I want backface culling set to false so that I can see underneath it and around it and just make it a little bit easier to visually digest. The rest of this here is just GUI. Now, I'm not going to spend time to go through the GUI in depth here. The one thing I do want to call attention to is when I hit this rebuild signal, essentially what's happening in here is I am disposing of all of the materials in the scene, just getting rid of them. And then I'm going to rebuild a new node material, reassign that to the ground plane. And again, of course, every time I do this, it has a random number of branches with a random number influencing each branch to a randomly chosen sine or cosine trigonometry operation. So, so cool. And then finally, I update the text that you see on screen just so that we know how many different branches there are inside of that node material. Okay, so we're going to skip on down now to where the magic happens. This is what we're all going to be looking at. This is going to be us actually creating a node material itself from code. Now, this is an incredibly powerful tool, again, that is not super widely used, but is something that is so, so awesome, especially if you want to introduce randomization into the equation, okay? Basically, what I'm going to do is I'm going to pass in my signal size. Now, remember, that's the number of branches that I want. For every branch, I need a random number as a multiplier to that trigonometry operation, okay? And so that's what this does here. We're going to start with this. I'm just looping through the number of branches, and I'm going to create, I have a new array called noise signal, and I'm going to add or push onto that array a randomly chosen number, okay? And that will be used later to pass into the node itself. Okay, this is the start of, this line right here is the start of our node material, right? We're going to create a variable called node material. I'm going to say new Babylon.node material. I give it a name, I give it the scene, and then any options. In this case, the option that I'm choosing is emit comments. And then we're going to start into actually doing the really, really cool work of step-by-step building out the nodes. Now, to create a node or a block, as it's often called in code, it's really, really simple. It's one line. In this case, I'm going to create a variable called position input. And then I'm going to say I want a new Babylon input block, and I'm going to call it position. It's that straightforward. Let's jump back over to our node material real quick so we can take a look at this. That is this node right here. That is an input block. You can see the type up in the top right-hand corner, input block. And then the next line here is position input. That's the input block. I want to set as an attribute position. So I want the attribute set to position. I want the mesh's position, okay? Now I am creating this node I create it with one line and then I set the attribute with one line. Then next I'm going to create a vector splitter node, okay? Now that is this node. Now notice that at this point I have 2 different nodes, and the nodes are set up to be used, but they're not connected to one another. So the first thing I want to draw your attention to is, as a practice, when it makes sense, build out all of the nodes first, and then come back to the order of connecting them up. That has been super, super helpful for me in creating this project and also getting into this space. Put out the nodes first, and then come to connecting them all up in the right sequence, okay? Now, there are a couple of exceptions of when that might not be the case, such as when I'm creating branches, but it's a good general rule to follow. So I have a series of nodes that are created. In this case, I have the position input, the vector splitter, the vector merger node, and that one is over here, this vector merger node, okay? And then I am going to loop. Now, this loop right here is where the magic truly, truly happens, okay? Now, notice at this point, again, I have not connected any nodes up until this point, okay? In fact, let's take a look, just jump ahead real quick. Down here, I actually have the section where I'm making node connections. And to connect a node, it is super, super easy. If the actual line that connects these two nodes right here is this purple line is actually this one line. I take the position input, that's this purple node, and then I am going to, the output of that node, connect to the XYZ input of the vector splitter node. And there you have it. The output of this node connected to this specific input of this node. It's that easy. So in just, 4 lines of code, I have these operations, this node, and then it's set to the attribute that I want, this node, and then it is connected, okay? But now let's go back up and take a look at the magic loop. This concept just blew my mind with the idea of I could randomly generate a number of branches to this node material. So essentially what happens here is I am going to pass in the signal, basically how many possible branches I want. I'm going to create a trigonometry block, okay? Then I am going to randomly choose if that trigonometry block should be a sine or a cosine operation. And that's what's happening right here, right? If this random value that's chosen is less than 0.5, set it to sine. If it's greater than 0.5, set it to cosine. And then I am going to create an input float, okay? Now let's go back and take a look here. So I am creating first this trigonometry node, then I'm creating this input float node. Now this here, notice, I am setting the value of the float for that, the value of the float for that node is going to be set to the first randomly chosen number based on what we created up here, okay? And that's what's happening right here. So now the actual numerical value of this float is set to that random value. Then I'm going to create a multiply block. And then I'm going to start to connect stuff together, okay? I'm going to say the vector splitter node, remember that's this one here, is going to, the X value is going to connect to the multiply block left, okay? And that's right here. And then I want the input float to connect, the output of that to connect to the multiply block right. And so now this spline here and this spline are now connected, right? And then of course you can imagine that my multiply block output will be connected to the trigonometry input, okay? And then finally, I'm going to keep track of the trigonometry node. This is just, I'm adding it to an array so I can keep track of how many that I have. That essentially is the process that we will repeat for the number of branches, the random number of branches we've chosen to create over and over and over again, okay? It is so cool that you can introduce randomization into creating a node material. It's absolutely amazing. Now, I'm not going to go into too much detail into this next part. It's basically just some logic that goes through and calculates how many addition nodes I need or add nodes so that I can create the proper number here. It's these gray ones that you see. To know how many, based on the number of branches that I have, how many add nodes do I need, and then which add nodes should be connected to which add nodes that eventually make a funnel down to one single add node, which is right here, okay? And then that is going to be used, of course, to pass into the Y value of the vertex shader. And the rest you probably are pretty familiar with. It's pretty awesome. And again, we're not going to go through the rest of this. I'm just creating a series of nodes and then I'm making the connections here. And that essentially is the whole concept. But because we've introduced randomization into a number of places, it creates a really cool effect. And now you have a procedurally generated node material. That is pretty awesome. Now remember, some important things here. You also need to have a vertex output and a fragment output in every node material that you're making, okay? And then finally, you have a line that builds it. Okay, so now this brings us to the 3 most important tips that you should remember if you're gonna get started down this path. The first tip, and potentially the most important as you're getting first started, is to start with the basics. I know, that sounds like an obvious kindergarten level thing, but in this case, I really do literally mean the basics, the basic set of nodes necessary for you to be able to properly build a true node material. And if you were curious what exactly that looks like, if you just go to nme.babylon.js.com, you will see this is the base set of nodes. You have to have a vertex output, a fragment output, and you have to pass things into those. Now, in this case, this is the most simple way to have your an object that is preserved with its position, not influenced, just via the world matrix, and with a specific color attached to it. That is very, very simply what this is. But if you go to our documentation, and you can find a link to this page down in the description of this video down below, there is a section in this called Building the Node Material. And under example, this code right here is essentially everything that you need to build your node material, your starting node material, this node material right here. And so what's fascinating is you can start with this and modify this. This is a great starting template. And this is a fantastic way for you to understand what it takes to create a node, how you make connections to nodes, and then you can start by interjecting new little things in this. For example, maybe you want to change the value of the color and see how easy that is. But this is a fantastic place. And the first tip to get started is copy and paste this example right into your code. And don't forget, you also need that build line as well to actually build your starting node material. And so that is tip number one. Tip number two is called the magic button. Yes, we know that creating a node material by hand is the creative part. That's where you want to get in and you want to experiment and try things. It's a lot easier to do that by hand inside of the node material, to add nodes in and try different connections. At least it is for me. And so what if you could combine the best of both worlds? What if you could have the creative freedom to create and experiment and find the right set of nodes as a starting place that you wanted, and then grab that code and then put it into your code to then modify? Well, you can do exactly that with the magic button. It is this button right here, the generate code button, okay? So let's say, remember that I'm looping through branches, but let's say everything other than the branches is something that I want to keep track of, right? Everything other than the branches and say the add node, okay? I want to delete these, okay? I'm gonna delete these nodes. I'm gonna pass Y across to Y, and then I'm gonna pass, let's just pass X over to this for now, just to give us something. So I now have a successfully building node material, and this is the base template of nodes that I will need, and then I want to add the branches to that. Well, check this out. When I hit this generate code button, and then I open this up, this is all of the code necessary to build exactly what I just creatively built by hand. And then, of course, now that I have this, I can copy and paste it into my code and interject the branch loop and the branch logic in the middle of this. So amazing. You have to take advantage of this button. It is a game changer. So it makes the process so incredibly fast and still introduces that creative freedom into the process, which is truly, truly amazing and inspiring. And then the final thing that I want to, oh, and look, see, I broke it. And so that's what we end up with, but we'll rebuild it. There we go. Now I have 25 frequencies in this one. The final tip, the third and final tip for this video, and for doing the process of creating a node material by hand, is log your nodes. What I mean by that is console log. Actually take the console log itself, okay? And not that, that's not the console log. Let's bring up the console log. Nope, try it one more time, sorry, my fault. There we go, now we've got the console log here. I'm gonna take the console log and I'm going to actually go through in my code, and I have a specific place in here, let me find it right there, where I'm going to log. Now in this case, I'm logging an array of add nodes, but you can log a node, and I wanna show you why this is important. Let me hit play here, okay? And then let's take a look at the console, okay? Now the console has output an array that I was keeping track of all of my add nodes. Now I actually, in the process, get rid of add nodes, so there's actually only one thing that's actually in here, but this is what you need to pay attention to. This is just an example. When you log a node, it gives you so much information. It gives you the name of the node, the type of the node, the nodes that it's connected to, and how it's connected. There is so much amazing stuff that you can have insight into, visual insight into understanding the state of every one of your nodes. So as you're going through and you're making your connections, log your nodes because it will tell you what you need to know. One of the problems that you'll encounter along the way is as you start to build your own things, it won't build properly. And so one of the things that you can do to debug is go through, log your nodes and actually see, oh, I thought I had connected this one to this one and it's not properly connected, or whatever the issue may be. But there is tons of amazing insight if you just log your nodes. So I hope that this has shown you some amazing possibilities, that you can see that you can generate procedurally or create procedurally generated node materials, that there is immense power and possibility by using code to create a node material and influencing that with randomization. This is a mind-boggling concept that I find so incredibly exciting, and I sincerely hope that it has helped teach you something new and given you some new ideas on how you can experiment as well. Thank you so much for checking out this video. If you have not already had a chance to do so, please consider subscribing to this channel so that you don't miss any future updates. And thank you so much for coming along this journey with me. We'll see you next time.